Chief Meteorologist Jeff Benson, one more time, take a look at that video. Your initial thoughts when you saw that, I'm sure, were like, wow, that is a great view, but also how quickly that happened. It wasn't there for very long.
No, it was a very, very quick event, John. The first thing that catches my eye, and that was incredible drone footage, a lot of those trees sheared off. Now, when you're talking about shearing, twisting, obviously that would lead you to think that it may have been a tornadic event. Just a really quick, almost like a pocket reference, when you're talking about severe thunderstorm wind damage. When you have a downburst, microburst, straight line wind damage, that's down. You get the downburst in there. That is because the wind is pushing down and flattening trees in one direction. And that is what the Weather Service determined in their first stop over in Seekonk there. Again, there was 2 separate damage surveys done today. Seekonk, they determined it to be a microburst with 100-mile-per-hour winds. A lot of trees down over at the high school facing in a similar direction, so they did deem that non-tornadic. However, the Rehoboth situation, we had a lot of trees lofted into the air. The report that was called in, 10 to 12 mature trees blown around 40 feet in the air. And that only happens when the winds are coming up or sideways. You get that wind shear, that is a sign that you may have had a tornado, and they did determine that to be a low-scale EF1 tornado, winds around 90 miles per hour. It was only on the ground for around a minute and only traveled about half a mile, but they were fast-moving storms again, John. They were around 50 miles per hour, so it didn't need to be all that long to go a fair distance and cause a lot of damage. And notice where the arrows are going over there on your screen there, right over a large wooded area. So what that does, you have lots of trees that can get lofted into the air. We have several radar products at our disposal, but an important one in a situation like this is something called correlation coefficient. What that is something, a parameter that is used to see different sizes of particles, raindrops, hailstones, snowflakes. But in this situation here, you can get a large response because of those trees and other large objects that could get lofted into the air. In this case, trees. We call this a tornado debris signature, a TDS. And you have many of those trees lofted up. It's a densely wooded area, and it leads to something that we call a debris ball. And that is a very defined signature that we got right there, and something that did point towards this being a tornado, and the Weather Service again confirming that event.